equation of motion. My previous video was regarding velocity time graph. I hope so that you have gone through that video and understood the topic. Today we will also, using velocity time graph, we will derive some equation of motion. So what is equation of motion? Now if we can represent the motion in terms of an equation which contains the different parameters representing your motion. That is, the equation will be consists of velocity, time, acceleration, displacement and so on. So in our course we are having three equations of motions, and those are, first one I will write, that is V is equals to U plus AT. Second one is S is equals to UT plus half AT square. And the third one is V square minus U square is equals to 2AS. So see, these are the equations which are representing the motion of a body. And these equations contains V, that is velocity. I will denote all these symbols here. So first I will write my U is initial velocity, and in this equation I have used V. The V is your final velocity. Okay, and then A is, as we are using, it is acceleration, and T is our time, and another term is that is S. So S is your displacement. Since we are going for straight line motion, we can say that the S may represent your displacement, or we can say that is representing the speed. So we will derive this equation, we will prove this equation by using the velocity time graph for a body which is moving with an acceleration, and that is our uniform acceleration. So these equations are valid for a body moving with uniform acceleration. So let us derive the first equation, that is V is equals to U plus AT. So you go through these three equations, remember these equations and what are the symbols denote. That is also important. So let us move to prove the first equation, that is V is equals to U plus AT. As I have represented here, U is initial body. So consider there is a body which is having a initial velocity U, and suppose at t equals to 0 it is having U, and after time, suppose t second, it has been reached here having a final velocity V with an acceleration of A, and it covers a distance of S. So this is our body having initial velocity U, A is the acceleration, V is the final velocity, and S is the displacement. So what will be the graph for a body moving with uniform acceleration? I have discussed in previous class. The graph will be, suppose, the graph of velocity time. So time will be represented along x-axis and velocity along y-axis. And for uniform acceleration, I had said that it will be a straight line. So since at t equals to 0, it is having an initial velocity U. So the graph will start from here to a final velocity of, suppose, V. Okay, and it has reached final velocity V at time t second. So first I will go for this equation. we denote the name O. This point is A, this point is B, this point is C, and this point, let me give a perpendicular here, that is D, and this point is E. So I can write here that OA is equals to U, and then OB will be equals to V. OB will represent V, that is final velocity, and OE will represent the time. OE will represent time T. Then this CD, what is CD? CD will be equals to AB, and I can find that AB is equals to OB minus OA. AB will be equals to OB minus OA. So AB will be OB minus OA. So what is OB? No, it is V, and minus O is what? U. So see, final velocity minus initial velocity. So that will give me change in velocity. Okay, I think you have understood up to this much. So CD represent me the change in velocity. So let us start. What we know? We know that the acceleration is what? It is the ratio of change in velocity divided by time. So change in velocity is how much? Now change in velocity is, that is CD, and what is the time? Time, for time I can write it as OE. So CD by OE. Then I can write CD is how much? No, CD is V minus U, and this OE is how much? T minus 0 seconds. So I have written it directly as T. So in place of OE I will write T. And for acceleration we are taking A. So see, we have proved that A into T cross multiply and V minus U, and that is V is equals to U plus A T. So see, this has been proved. The equation 1 has been proved. So if the question comes, derive the first equation. So you just go through this procedure. Now let us derive the second equation also. That is your S is equals to UT plus half AT square. So students, go through it. This one is our important derivation. Now let us derive the second one, that is S is equals to UT plus half AT square. So for this I will use our previous knowledge that we have discussed that the area under velocity time graph gives us displacement. So since we want to find out the displacement, we will go for the area under this graph. So let us go for this for the area under velocity time graph, and we will find that this much value will come. So we know, first you will write the area under V versus T graph is equals to the displacement. So displacement is equals to the area under V versus T graph. So what is the area covering under this graph? This is our graph. So what will be the area? The area is total. This much area will be covered by this graph. So area under V versus T graph is the area of, see this is a trapezium, so I will write area of the trapezium OACDE, area of OACDE, again O. So the area will be this much. So if we can find out what is the area under this graph, we can find out the displacement. So displacement, for displacement I can write our expression as. So now see, this area of trapezium can be divided into two areas. One is area of this right angle triangle, this one, and the rectangle area, that is this one. So I will divide this area into two parts. First is area of ACD, triangle ACD, and plus area of rectangle, the rectangle what? OADE. So see, what is the area of ACD? It is a right angle triangle. So half base into height. What is the base? Base is AD into what is the height? No, height is our CD. So for area of triangle ACD, I had written this much. Now add, I am writing here, plus area of this one. So for rectangle formula, length into breadth. What is the length? Now OE into OA. So now put the formulas. Half AD. So AD is how much? No, AD is equals to OE. AD must be equal to OE. So in place of AD, I will write T, and in place of CD, I will write V minus U. Then plus OE is T into OA is U. Again here I will use one formula, that is, we know that V minus U is equals to A T. So half into T, V minus U is equals to A T plus U T. T into U, that is U T. So T into A T, it will give us half A T square plus U T, and here we can write it as S. So you are getting S is equals to UT plus half AT square. So students, see how I have proved. You first go for the area under this, that will give us displacement. Then divide this into two areas, area of a right angle triangle and the rectangle. Put the formula and put the values, you will get the second equation of motion. So practice these two equations. In next class, I will go for the last part of this motion chapter. Thank you, students.